Now let's look at some of the values for albedo. Can you guess what is the range of albedo? From 0 to 1, where 0 is the most absorbing. It doesn't reflect at all. Where 1 is white, where it reflects all the light, or all radiation from the surface. So albedo simply is just the reflectivity of the Earth's surface. So here is the clear sky albedo values for different parts of the Earth. The range is from 0, black, where it wholly absorbs radiation, to white, which is 1, where it all reflects. So notice the albedo value for the ocean, because it's blue and green, is actually quite low. The albedo values are quite low for blue and green. But it kind of makes sense for plants, right? Because he wants to absorb the energy as much as possible, not to reflect it. Different land use gives different albedo values. So these are some that are, I think, relevant to urban areas. Earth average, that means for the entire world, is between 0.3 to 0.35. That means these are very low, very high albedo values. You know why, right? Because it's at the North Pole or the South Pole, where the surface is mostly covered by ice, white in color. But somewhere in the middle here is quite low albedo value, because it's, the color of the ocean is blue or green, so it absorbs more. Here is low albedo because it's the desert. It's made of sand, and sand is mostly white and reflects light back out, so on. Now, Earth average is 0.3 to 0.35. This is the reference. For fresh asphalt, means tar roads, those black roads, 0.04. For worn asphalt, you notice that as the tar gets older, it becomes whiter and whiter. So that becomes 0.12. Bare soil, brown in color, is 0.17. Green grass, because the color green, and it also needs to absorb because of photosynthesis, is 0.25. New concrete is 0.55. So you notice that most of these are for urban surfaces. And most of the time when you run air quality modeling, you run it in industrial areas, urban areas, or close to urban areas at least. So these values can be useful for you to use as a reference if you don't know what the surface characteristics are. So typical albedo values in urban areas is the highly reflective colored paint, 0.15 to 0.25. What's that? Corrugated roof. White paint, 0.5 to 0.9. Tar and gravel, 0.03, 0.13. Red brown tile, 0.1, 0.35. So albedo values in percentages, including by clouds. This is percentage from 0 to 100%. So snow fresh, snow oil goes from 0.4 to 0.9, and so on. Right? So you can see it from there. Different albedo values from different surfaces. Because this is a basic parameter that you need to input into the model. They will ask you for the albedo values of the surface. And these are the values. And when you look at your surface, you need to choose the proper albedo values for that area. So Bowen ratio is the ratio between sensible heat to latent heat. So like albedo, Bowen ratio describes the characteristics of a surface. So if the Bowen ratio is low, means that there is a high moisture content in the air, or at least at the surface or near the surface. If the Bowen ratio is high, that means there is a low water content in the air. So Bowen ratio could be low over the ocean, but it could be high over the desert surface. Sensible heat is heat transfer caused by temperature difference without contribution from evaporation. So it's just the heat transferred because of temperature difference, or in other words, dry heat. There's another form of heat called latent heat. That means heat associated with water evaporation. Latent heat is heat transfer caused by moisture difference, also known as evaporation. Two different main types of heat. Now, urban areas have larger Bowen ratio because of the higher sensible heat from concrete buildings. But in Malaysia, we generally have high Bowen ratio because of all the humidity there is in the air and because of the vegetation. The vegetation also releases moisture into the air through transpiration, respiration, and so on. Respiration. So over, of course, say Dubai, then it'll be quite low. The bone ratio will be quite low, or over dry areas, the bone ratio will be quite low. So the range of bone ratio is not from 0 to 1, but it's still dimensionless. It's from 0, wet surfaces, means very high water content, to 10, dry surfaces, very low water content, or no water content at all, from 0 to 10. Bowen ratio values over different types of surfaces taken from, I think, Wikipedia, you can find. So these are the values. Types of surface, if it's deserts, it's more than 10, like what we expect. Semi-arid landscapes, that means quite dry, 2 to 6. Temperate forest and grassland, not us. This is over in the higher latitude areas, 4-season areas and so on, 0.4 to 0.8. Tropical rainforests, like us, 0.1 and 0.3. Tropical ocean is less than 0.1 because of all the evaporation. So here we can get some guess Bowen ratio values too to be input into the model based on the types of surface. Now for us, maybe the most often is the tropical rainforest, which is between 0.1 to 0.3 will be a good estimate for Malaysia. Okay. Now surface roughness or roughness length, they're the same. Is the degree of roughness of a surface in meters. It's just the height, quite simply. So the higher the amount of objects on the surface, the higher the surface roughness. If there are more obstructions on the surface, there's more buildings, trees, and so on. Of course, the surface roughness of that surface will be higher. So that would be denoted, would be obvious in the length of this roughness length. So some roughness length values, let's say the open sea where it's really flat. So the roughness length is 0.0002 meters. That's very, very thin. Farmlands where there are trees, there are crops and so on. But here I think they mean to represent the farmlands over in like say US or Europe where they plant wheat, corn, you know those height of plants that is about this high. Not like oil palm. Oil palm is quite tall. So this is what it means by, I think this is what it means because the roughness thing is not so high at 0.2 and 0.5. If it's over forest, then it'll be about 1 meter. And oil palm plantation, for example, they're quite tall. So the roughness length for that will be mostly 1 meter to 2 meters. Because the height of the oil palm is about 16 meters. So it's not 16 meter roughness length. It's below that, it's about 1 to 2 meters or so. Rural areas where there are some trees and there are also houses, buildings, it's about 0.1 meter. Scattered objects, 0.5. Urban, you see, 1 to 2 meters. The same goes for tropical rainforests or forests. It's quite large because of the obstruction on the surface.